There's a new T-Rex in town, and this one is from Texas. Instead of ruling on land, Tylosaurus rex was a massive marine reptile that swam the ancient seas during the late Cretaceous, chomping on prey and sometimes even its own kind, with its unique serrated teeth. I'm Stephanie Edwards, and in this video, I interview Dr. Ron Tykoski, Vice President of Science and Curator of Vertebrate Paleontology at the Perot Museum of Nature and Science in Dallas, Texas. As co-author of the study on the new Texas T-Rex, Dr. Tykoski talked to me about the significance and sheer power of this new mosasaur species and how museum collections play an integral role in scientific progress. So my first question is basically just how did you get involved with this research? How did you kind of get involved with this project? What kind of led you to this?
So my involvement actually came a little bit later in the process. So this really was Amelia PhD work. She's been working on mosasaurs, working out the evolution of this group and finding new species and doing things like that for a number of years as part of her PhD project. And Mike Paulson over at SMU, I believe, is a committee member of hers. And so he's an expert on mosasaurs as well. And Mike and I, we've worked together on a lot of things and bounced back and forth into each other quite a bit here around Dallas. Over the last several years, I've been involved collecting a handful of these, oh my gosh, 3 or 4 of these in the last decade and a half while I've been here at the Perot Museum, about 20 years now. So we've accumulated several more of these big Tylosauruses from the rocks around here. And our team prepped them up, oversaw a bunch of that and things like that. And so I'd overseen the collection and preparation of several of these, and I'm in charge of the collections here at the Perot Museum. And so when Mike and Amelia came by to research, continue to work on her project, of course, they came through and looked at our big, beautiful, exquisite specimens here, plus the big one on exhibit downstairs has been there since, it's been on exhibit since the 80s, was found in the 70s. After a bit, they really got it connected in their head, like, wow, these guys are notably different than other Tylosauruses. They should be something else. They asked if I'd be interested in joining in on it because I knew, I had dug up several of them and understood the geology pretty thoroughly. But really, I have to give total props to the heavy lifting of this project. This is Amelia's baby right here.
Yeah. Kind of speaking of that, like, how does this research kind of highlight the importance of not only like museum collections of like being able to have these specimens for decades, years, and then be able to be at the forefront of these new discoveries, but also kind of highlighting the importance of science education and PhD students and their kind of interest and curiosity. How does this story sort of embody those two kind of important aspects?
Part of our mandate as a public repository, we're a private, not-for-profit museum organization, but we take that very seriously, and the stewardship of specimens seriously. We are a repository for federal specimens, but obviously lots of local things or whatever that actually belong to the museum. And part of my job is making sure that these incredible resources are here in perpetuity for research like Amelia's. It kind of tells us a little bit of the story of not only were we going out and actively collecting these things as they were turning up, they mostly being found by local amateur collectors and enthusiasts were the ones finding these beautiful specimens. Mm-hmm. And then we were going on out with their help, the Dallas Paleontological Society, oftentimes helping out quite a bit. That's an amateur group of fossil enthusiasts here in North Texas. They were a lot of the heavy lifting and digging between a lot of this. They're the manpower, the force multipliers. But getting those things here, and so many of them kind of in a short period of time, this is why we continue to collect, because it was only after enough of these, specimens that were well preserved enough, complete enough, were actually in collections, that somebody like Amelia going around checking out dozens of collections all over North America and the world and seeing this huge data set of these animals, only then do you have the scientific basis to sit there and go, this isn't just one freakishly unusual individual. This is a population of individuals all from one place, from just a couple of rock formations that are all about the same age. And that's a population, and it's distinct enough from everybody else to recognize it as a new species. We are the repositories of scientific information in the form of specimens. And it's partly my mandate to see to it that that information is accessible to qualified researchers.
Yeah, and kind of speaking of the data set, how's this going to kind of help? Like, I know the kind of press release and the coverage on the museum site sort of like talks about it a little bit, but you know, what can you talk more about like the importance of this sort of new data set and these new discoveries and kind of like the evolutionary history of the mosasaurs?
This happens, you know, people get in kind of a rut on the research world. You know, somebody comes out with a big data set on whatever group of animals, be it dinosaurs, mosasaurs, mammals, whatever. And for some number of years afterward, everyone just keeps adding more characters and maybe has new species and new things are found. And so you get sort of constrained by the same things being looked at over and over again. And it kind of stifles new discovery sometimes because you're all just building on the same old tired thing. And every now and then you get to a point where you go, you know, the old data set just doesn't encompass enough or everything, or maybe we need to look at it with completely fresh eyes. And somebody sits there and goes, you know, I'm going to do the hard work and I'm going to start from almost zero and start a whole new thing. I'm not going to just replicate this person's work and just add a couple more things to it. This needs to be completely thrown out and started from scratch. And that's what Amelia did. I suspect that in the years to come, her data set, the one in this paper, will be the one that people jump to and start building upon. And it'll become the dogma for the next 20 years, you know, or 20 or 30 years, till somebody gets tired of this one and decides that it needs to be further expanded upon. And that's part of the nice thing, too, that it's an open access venue. So anybody with a computer anywhere on the globe can log in, pull down the paper, pull down the data set, pull down the exact files that she used to build this, and test it or add to it and grow it and move the science forward, which is what we're constantly trying to do. And it allows you to, you know, like, oh, here's a set of relationships that the previous dogma, the previous data sets that have been slowly built, maybe didn't recover. Oh, that's something new. That's something novel. Oh, that's a leap forward. You know, you can get really stuck in a rut and you're just replicating the same thing over and over again. Or you get to this point, something like this, where it's suddenly, you know, we gotta rethink our shift our thinking, and boom, suddenly there might be some new relationships in there that people go, what? It doesn't look like these previous ones. Well, no, it's because it's, you know, reshuffled, rethought, threw out some characters that maybe weren't valid or maybe reinterpreted. This is why it's fresh, folks.
Mm-hmm.
And now what's a great thing is the scientific method operates by disproving, by testing and falsifying. So if somebody doesn't like what they see, excellent.
Yeah.
tell us we're wrong.
Yeah.
You know, that's how science advances. There's a public misconception, and
Yeah.
my wife's a school teacher, has been for 30 years, and she's worked very hard to try, a science teacher, and she's worked very hard to try to explain to students that science isn't about proving anything. Science works by disproving things, and all you have to do is disprove it once, and you got to redo it.
Yeah.
You know, and so I love throwing it out there, and I love having people come to me and go, you know, I think that this thing that you claimed, you know, 15 years ago was wrong. I'm like, good.
Great. Yeah.
That's what we're supposed to do.
That's wrong. Yeah.
Prove me wrong.
Yeah.
You know, kind of a thing. Please. Mosasaurs have a great fossil record globally. You know, they conveniently like to live and die in shallow, warm seas. Great place to be buried. Great place to make it in the fossil record. So there's a good number of them around the globe. And so people will have lots of specimens they can compare and contrast, and this gives us a little bit better picture of, you know what, these guys were way more diverse than appreciated before. And I think that's one of the other big things of Amelia's work. It's not just Tylosaurus rex here, but in some of her other things, she's been finding, you know what, we need to split up our long-standing recognized mosasaurs into more species. You know, these were more diverse lizards than appreciated. And given the amount of time they lived and the global distribution they had, yeah, they probably were more diverse than we have a record for. It's a little hard to tease apart the fine details out of just bones.
Yeah. Yeah, and that's exciting to kind of have that fresh data set and, you know, be able to have that new information for new sets of eyes. And And kind of one of the things we mentioned, kind of like the differences between the different species. And I know in this one, the kind of paper mentioned the serrated teeth, of course, and kind of their penchant for violence, which of course are very like, the public's going to love that, right? I'm sure you jump in.
Something with big teeth beating the crap out of each other. It's basically Godzilla fighting, right? Yeah, exactly.
Exactly. I was just curious, like, why, is there any idea kind of like why this group maybe evolved that, even though like, the kind of Kansas specimens sort of show a difference, like why, why over, and I know, 4 million years sounds long to some people, but in the history of mosasaurs, not it's kind of like a blip, right, between that one and that one. Why do you think maybe they evolved these kind of two things that make them distinct?
Those aren't the only two things, but definitely the features that you see that sets Tylosaurus rex off from its closest relative, Tylosaurus prowrigger and friends here now, is the size, and not just overall linear size, but man, they really beefed it up. They jaw musculature, attachments in the skull, things like that are more pronounced in this animal than the others. So these things, you see something like that, it's like, okay, these are evolving even more powerful bites. They're taking larger prey. They're flipping their head up, gaping wider and slamming teeth down harder. And then even the design of having these, micro serrations along the tooth edge, just like a steak knife. Why do you have little bumps on a steak knife instead of a smooth edge on a steak knife? Well, it's because it helps saw through meat better, right? Same thing in nature. And so these guys were getting even more efficient, more effective at puncturing meat, processing and tearing, cutting through things, stronger jaw bites, heavier muscles in the neck and the head. Anytime you see that, it's like, wow, carnivory, predation. As far as the other features, like behaviorally, yes, we do have a specimen here in the Perot Museum collection. It is in process of being written up in a second paper here.
Yeah.
Me and Mike and Amelia. This one we nicknamed the Black Knight for Monty Python and the Holy Grail reference, because there's part of its face that was removed and yet it lived. It's like it came out of a joke. We were, around here like, oh, this thing's like, oh, it's only a flesh wound, kind of a reference. It's like, oh, it's the Black Knight, and then boom, name stuff from then on, kind of a thing. The only other organism around in this place at this time that could have inflicted those on it is another one of its own species, because that's the only other game in town, the only thing big enough to do it. And so you look at it and go, man, these things were that just had to be an incredibly violent interaction between these animals when you look at the injuries on this individual, which again speaks to they evidently didn't like each other, or were very territorial or something, or maybe they were cannibalistic. We don't know the exact why. All we know is that this one got its rear end handed to it big time, but lived.
But still went on, yeah,
for a while afterwards. And then there's the size. These animals are notably larger, and you plot up size distribution of these. They're notably larger than Tylosaurus prowrigger. Once you pull them out of what had been a prowrigger population, well, now you pull these ones out, and okay, here's prowrigger now, and here's Rex here now. They're large, and even the ones, even amongst them, the size difference is pretty impressive. I actually pulled here's a vertebra of one of these from about the size of the whole type. So this is near the base of the near the base of the tail, and it's probably to an individual 35 feet long, give or take. And from the same rock formation, from along the same river. Here, let me turn them right the same way. So you're looking at the back end here, right? Rounded back end. From the same river. So here's a 35-footer, roughly. We don't know how big, because we only have a few bones of this one, but good night, nurse. Look at the size difference here.
Yeah, that's wild.
All right, so this is minimally 40 plus feet in length. Perhaps somebody could do some extrapolations on this size based off the other one and say, no, actually it's more like 45 or maybe 50. I don't know exactly, but that really does give you a sense of like, oh my gosh, these were huge lizards.
Yeah, like reading it's one thing, but then seeing that comparison is really puts it into perspective.
Most of the time people find these things, enthusiasts walking out in the rivers and creeks, people digging out a cattle pond in their yard on the ranch. The holotype was found in 1979 by a family boating on a local reservoir, and the kids got tired and cranky and said, Mom and Dad took him up, beached it on the shore, said, go play and burn off some steam, and the kids found bones.
Dug up the
Yeah, and so it's usually the public who finds these things and brings them to our attention. We don't have big rolling badlands with thousands or tens of thousands of acres to work with. We're in heavily vegetated, a lot of prairies, a lot of woods, a lot of pavement, and things like that. And that's usually in these very small areas where something gets disturbed, or a shoreline or a creek or construction site where these things pop up. But they continue to pop up. I'm sure we'll find more. I could get a call any day now and say,
got another one.
I'm like, great, here's been another hot summer at 105 degrees digging out a mosasaur. All right.
Yeah. Living the dream, I'm sure. I'm sure young you would be very excited.
Yeah. Sounds like it till you're doing it.
Yeah, true. Yeah. I took a few archaeology classes and that was enough. Yeah. For the future, like, thinking about the future, kind of to end it off, you mentioned kind of you're working on a second paper on the Black Knight, and if people bring in new specimens, is there anything else kind of on the immediate horizon for either studying this specimen or other specimens that you're currently working on?
Yeah, basically with regard to our mosasaur friends here, our Tylosaurus rex friends here, our next focus will be the paper describing the horrific injuries suffered by the Black Knight and what those implications were for the behavior, the paleobiology, the physiology of these animals 80 million years ago. Sometimes things like that can give you some unique insights and a better appreciation. That's another thing too. These are living, breathing animals. They weren't movie monsters.
Yeah.
They weren't Godzilla. They weren't Jurassic Worlds. They weren't whatever. They lived, they died, they bled, they ate, they tried not to be eaten, they tried to make more of themselves, the whole thing that animals do in nature. And so a discovery like this, like Amelia's work, and then the specimens that we house here, the SMU houses there, these really do just give us these faintest glimpses, these little snapshots of life in the past. And as paleontologists, it's our job to try to interpret those best we can and then relay them to the public and tell these stories and inspire people and get people excited. And whether or not kids who like, I want to be a paleontologist, stay in paleontology, poor souls. Or if it simply sparks some interest to make them start looking at the world and get excited about something in the natural world, something in the scientific realms, anything, as long as it inspires them and gets them out there and puts them on a path to success, outstanding.
Yeah.
And if they want to come, if anybody wants to come and actually see the holotype of Tylosaurus rex, it's the skeleton. It's actually the one that the kids found on the shoreline of the lake in 1979. It's on exhibit at the Perot Museum. We put it out there because, wow, it's a really cool 36-foot long skeleton.
Yeah.
Didn't know it was going to be a holotype in 2026, did we? So.
Yeah.